Myself, Dr. Chuluka Ramesh, co-organizer for this event. It's a privilege for me to invite Dean and Head of the Department, Dr. K. Gautam Madam, to share opening remarks. Madam, please take over the session.
Good evening to all. This is Dr. Gautami. It's a great privilege to me to welcome you all. Ladies and gentlemen, the Department of Electronics and Communication Engineering of Malineni Lakshmaiah Women's Engineering College, in association with Make Skilled, are welcoming you. This program runs under the Corporate Innovation Accelerator of Make Skill. I thank Mr. Parvataneni Madhu, CEO of Make Skill, for being a technology partner with Malineni. The initiative taken by the department is mainly concentrate not only the regular academics but also to enrich with the new technology. We have a phenomenal lineup with thought leaders from industry people and academicians such as Dr. Sridhar Patnaiak, Dr. Radhakrishnan, Dr. Vandana C. Bhagal, and Mr. Rohit to transfer technology on this training platform for all these 6 days planned. And this event is witnessing a high level participants of faculty of various universities, researchers, and interested learners. And this training program includes hands-on session on both Ethereum and Hyperledger. And I assure that this platform integrates all the applications using Ganeshi, Truffle, Solidity, Python, etc. I hope and wish this platform will give you a fruitful transformation towards technology. And I acknowledge our team who worked tremendously to bring this platform. And I am truly honored to honor our beloved chairman, Sri Dr. Perumaldu Garu, to place this inauguration within a short moment. Thank you, and all.
Thank you, Madam. Now it's my privilege to give introduction about Dr. K. Sridhar Patnaiak Garu, today's speaker. He's going to.
CH Ramesh sir.
Yes, Madam.
Our director is in line, sir.
Yes,
Sir
Madam.
is
But
in line. Yeah, you call the PNR, sir.
SAR is having only listen mode, Madam. I think it should be changed to.
What was the name, sir? I was just looking at.
Padibandla Nageshwara Garu.
Acha, one second, sir. I'll give him my.
I think SAR just disconnected.
Yes, sir. I guess. Can you ask him to join, sir? Like, I'll give the permission.
Not online, sir.
He's not available, sir, in the meet.
Okay. I think there is some technical issue at his side, sir.
Okay.
Madam,
So,
shall we proceed?
Yes, sir. You can give the brief introduction of Dr. K. Sridhar Patnaik, sir.
Sure, ma'am. Dr. K. Sridhar Patnaik, sir, is an associate professor in the Department of Computer Science and Engineering. At Birla Institute of Technology, Misra, Jharkhand. He has 19 years of teaching and research experience in the field of software engineering, machine learning, and medical imaging. He has published many papers in international journals and conferences. He is also working in IoT and blockchain technology. He has done his PhD in collaboration with University of Manitoba, Canada, and worked on designing intelligent systems using UML design patterns. He also worked on various reinforcement algorithms. He also many publications in reputed journals and conferences. He also published book chapters and delivered talks in training and workshops. With these few words of introduction of Dr. K. Sridhar Patnaik Garu, we welcome Dr. K. Sridhar Patnaik, sir. Please start the session and enlighten us with introduction to blockchain technology.
So good evening, everyone. My voice is clear.
Yes,
Yes,
sir.
sir.
Okay.
Audible.
So thank you so much, Madhu sir, and the entire team for giving me an opportunity to share my views on introduction to blockchain technology. So
Sorry for the inconvenience for connecting of all these things, sir.
no issues, madam. Online will have always some glitches, one way or the other way around. No problem, madam. Most important thing is whatever the knowledge I have, I should share with you all. So that is very important.
Thank you, sir.
Oh, welcome, madam. So my screen is visible.
Yes, sir.
Okay. So good evening once again. So let me start the session, the first day session. Now, I'll just give a general idea about what blockchain mean to us, because most of the audience probably from electronics and communication engineering department. So I'll start explaining the things in that direction in such a manner that even a layman can understand what blockchain actually mean to us. So as my introduction is already given by Ramesh sir, thank you so much, sir. Now, when I talk about blockchain, blockchain is nothing but a decentralized computation and information sharing platform. Now, how we have shared information in the traditional way? Okay, that I'll explain. Then slowly we'll move to the need of blockchain in the current scenario. So these terms, one is decentralized computation and information sharing. That enables multiple authoritative domains who do not trust each other. Now, this trust plays an important role in a blockchain ecosystem. Okay, why this decentralized came into existence? Because we people don't trust on each other, so we don't want to depend on any central authority. Okay, so who do not trust each other to cooperate, to coordinate, and to collaborate, where in a rational decision making process. Okay, so when you are in a mechanism where you have to make certain decisions where a lot of people are involved, then obviously you have to trust on each other, you have to cooperate, you have to coordinate, then you have to collaborate. Then only whatever the decision that will be taken care will be welcomed by each and every individual. Okay, so let us start with the traditional way. The traditional way of sharing information is, for instance, there is a person P and P1, and there is another person P2. So P1 is changing this particular document, and then he sent this document to P2. Again, he will change. Okay. The problem with this architecture is that both cannot change this particular document simultaneously. Okay, so this is how we have done sharing of information in a traditional way. In the earlier ways, when we don't have a concept of cloud computing or Google Docs in a cloud environment. So in that tenure, each and every individual has to change that or edit that copy, and then is sent to other persons who are going to edit that. Okay, so the problem with this architecture in the traditional way of information sharing is that both cannot simultaneously edit the document. Okay, so this is what we have came across in the earlier days. Okay, now when Google come up with this technology where the cloud plays an important role. Now there, the shared Google document, what we have only one document. Okay, so there is that particular document. So J is one particular person. He says the document. So after he's sharing, Piri is also sharing the document. Okay, now what we are seeing here, both are sharing this document simultaneously. This is not there in the previous case, in the traditional way. Now, when Google came with this document sharing mechanism, now two people can share the document at the same time. Something that we have all witnessed nowadays. Okay, we are sharing the Google Docs and everybody is trying to update that. Okay, So this is what we have experienced, that both can edit the document simultaneously. But what is the issue with this? It is still centralized. Somewhere in the first slide I mentioned decentralized. But why before coming to the decentralized, we must know what is the centralized mechanism. So there is a centralized mechanism. One document is changed by several people. Okay. And this the algorithm that is running behind this technology is nothing but that is still a centralized way. Okay. For instance, if you talk about banking example, so everybody have got an account in SBI, SDFC, and all. They all works on there is a central bank server. Okay. All your transaction will be kept in that central bank database itself. Okay. Only bank has got the complete authority. Okay. Now the issues with the centralized system is that if you do not have sufficient bandwidth, then the Google document is not going to upload from the Google server. Okay, so that is an issue. Okay, and there is a possibility that if the server crashes, then nobody is going to change that particular document, because all these particular users, they are dependent on this particular central server. If this crashes, then you can't access any of you can't access this particular resources for your applications or other data sharing. Okay, so that is the biggest problem that we have faced as far as the centralized system is concerned. Okay. Now to overcome this, let me move this. Now, what is a plausible ideal solution in this particular scenario where we can come up out of this ecosystem called centralized mechanism? Okay. Now everyone edits on their local copy of the file document. Okay. Now you see here in the previous example, I have mentioned that one document is shared by each and every individual. So in that case, if the server fails, then you can't able to change or update the document. Now just imagine that every person have got their own local copy here. Now Jay has got his local copy. Viru is a person, he has got his local copy. Now they are going to update this. Okay, because they have got their own local copy, they can update, delete, whatever they want, they can do it. Okay, so now that's why I mentioned the plausible ideal solution where everyone edits on their local copy of the file or a document. Now the internet takes care of consistency here. Okay, so consistency means whatever the updation you are doing, this particular person is doing, and whatever the updation this particular person is doing, after all, one particular document, the final document should be there, where whatever he has done, the edit, whatever the edit he has done, everything should be reflected on the final document. So that is what consistency, and that is taken care by this internet itself. That internet is nothing but what you call a blockchain now. Okay, so the changes in the documents are synchronized over this particular network. Okay, so the decentralized database with strong consistency support. Okay, because why this is decentralized? Because every person has got the local copy. There is no central server as such. Okay, so whatever the network we have, all these networks, okay, so these networks are connected. Okay, so every node or a person has got their own local copies. So each and every person can edit or update this local copies, and the consistency is taken care by the internet, where so that is a key here. Okay, how you are going to achieve the consistency, and that is taken care of by this network itself, and that is nothing but what you call a blockchain. Okay, so the point is that the changes in the docs are synchronized over the network, and that is taken care by this blockchain network itself. Okay. So if you have any doubt, you can raise your queries in between so that I can answer. Now let us come to the simplified form of a blockchain. Okay, as I mentioned that this is a network and there are several computers are there, several nodes are there. Okay, so every node maintains a local copy of the global datasheet. So every node has got the local copy and they are connected to each other in a network. Now the system ensures the consistency among the local copies. Okay, so that is the key here. So local copies at every node are identical. Local copies are updated based on global information. Okay. Now the consistency has to be taken care by this network itself. Okay, based on some algorithms that are running at the background. But the key is that there is no central authority here. Like in the banks, we have got their own central server. Okay. Amazon, Flipkart, they all have their own servers. Okay. So local information means what? The public ledger or a historical information available to everyone. Okay, everybody has got the copy of the file. Okay, so there is nothing but what you call a local information, what you call public ledger, and this public ledger or a historical information is available to each and every individual connected in that particular node. And this historical information may be used for future computation. One is for banking transaction. So whatever the transaction you do, that is available with the bank itself. It is not shared with everyone. Okay. So the old transactions are used to validate the new ones. I'll just give a simple example how this is happening. Okay. But the meanwhile, if you talk about banking transaction, whatever the information or whatever the transaction you are doing with the bank, okay, that will be updated by the bank official itself. Okay, it is not accessed by any other person. Okay, so that is accessed by the bank authorities. So whatever the foreign transaction you do, they update the older one and they put the new one. Okay, so let us explain with a simple example with reference to what we do when you do some sort of transaction, or when you visit bank and do some transactions. Now with reference to the banking sector, so there is a public ledger. Okay, now there are 4 persons are there: Jay, Viru, Vijay, and Vinny. Okay, so Vinny is a person here. 4 persons are there. Now you see the public ledger means everybody must have the same copy. Okay, so public ledger of J, okay, rupees 100. The same copy you will find everywhere. This is what I have shown in the previous diagram. Okay, each and every individual node or a client has got their own local copies. Like here, this one, everybody has got the same copy. Okay, now let us uh, consider this particular example where Jay is making one such transaction where he want to send rupees 40 to Viru. Okay, so everybody knows that Jay has got rupees 100. Everybody has got the local copy of public ledger or a document. Now he wants to send rupees 40 to Viru. Okay, now let's see what happens here. I think the slides are not moving. Am I audible?
Yes, sir, audible.
Okay, but the slides are not moving actually. Let's see.
This side only. Last slide is okay.
So you are in the slide that public ledger banking sector?
Yeah. Yes, sir. Public ledger banking sector.
Not moving ahead. Madhu sir is there?
Yes, sir, I'm there.
Sir, the slides are not moving actually.
Maybe exit this slideshow and present it again, sir. Maybe.
Oh, just a minute. Now it's okay. Screen is visible,
Same.
Madhu?
Yeah, it is. It is the same slide, sir. Public ledger banking sector.
Yeah. Again. Options are not coming here on the screen. Madhu sir,
Sir.
options
Can
are
you
not coming on the screen.
Are slides moving on your laptop, sir? Is
No,
it going to
it's not moving.
not moving?
The mouse keyboard, nothing is working here.
I can able to see your mouse position, sir.
But I am not able to see. Let me join once again. Just disconnect me.
1 second.
Hello,
Hello.
madam,
I,
voice is clear.
yeah, yes, sir. Voice
Okay,
is clear.
this screen is okay now.
Yeah, public lecture.
Yeah. Okay.
You
So
can start.
sorry for that small interruption here. Now this is what we have started here. So there is a public ledger. This copy is there in everybody's account here. All the persons have got this public ledger of J. And now the status of the J's account is 100. That is there with everyone. Now he wants to do a transaction. He wants to send 40 rupees to Viru. Now this particular transaction from J to Viru has to be reflected in each and every person's personal node. You see here, now J is sending a rupees 40. Now this will be there everywhere. You will find the copy of transactions. So in a distributed environment, so whatever the transaction that takes place, that copy will be there reflected in each and every individual person's account. Okay, so you see here a particular transaction has been made from J to Viru and is reflected in everybody's account here. Okay, then now for instance, Viru want to send rupees 30 to Vijay. Okay, so this is what I have shown here. Okay. Now, since the first transaction that was made from J to Viru, he has sent already 40. Now he has left with 60 rupees only. Okay. Now J has got, now Viru has got this 100 and this 40 has sent by J to Viru. Now he has got 140. Now in that 140, he is sending 30 to Vijay. Uh, okay. Now this 30 rupees transaction from Viru to Vijay will be reflected in all their corresponding accounts. You see here, everybody is seeing the transaction that is made from Viru to Jay. So whatever the transaction that you make, it will be reflected in each and everybody's individual ledger or a copy of the document. Here you see, if Jay wants to send rupees 60, rupees 80 to this particular person called Vinny. Okay, now in that case, because I know that earlier he has got 100, he has already sent 40, he has left with 60. Now he can't send rupees 80 to this particular person called Vinny, and this transaction is invalid. And this invalidity of this transaction has to be verified by each and every individual in this particular network. Okay, okay, so there's a key here. So if there is a transaction which is invalid, that invalid transaction has to be declared by each and every individual. If, for instance, as I mentioned here, Jay has already sent rupees 40 to Viru. Now he can't send rupees 80 to Vinny because he has already 60 rupees in his account. Okay, so this transaction is invalid, and this validity and invalidity of the transaction has to be taken care by each and every individual in this particular network. Okay. So now the blockchain works as this public ledger. Everybody has got the copy of that public ledger. Is nothing but a blockchain. However, the following has to be ensured. Okay, no doubt that each and every individual has got their own copy. They can do update, transaction, whatever they want. Okay, but there are some points to be remembered here. The first one is the protocols for commitment. Ensure that every valid transaction from the clients are committed and included in the blockchain within a finite time. So whatever the transaction that you make, each and every transaction that I have shown in the previous slide for an explanation, it should be valid. Okay, if it is invalid, it won't be a part of the network. Okay, so that's why ensure that every valid transaction, valid means that I've already shown that rupees 80 that is sent, that is invalid. Okay, this example. So this transaction is invalid. It can't be added into the blockchain. Okay. Data needs to be tamper proof. So whatever the changes that you make, those changes cannot be updated or deleted once it is committed in the network. Okay, so if you want to do any transaction, you have to do a fresh transaction. So that's where the data needs to be tamper proof. The clients may act maliciously and can compromise it. Okay, so that we'll discuss in detail. But the security plays an important role because everybody knows what type of transaction that you are validating it. If there is any incorrect transaction, so that is not be the part of your network or the public ledger, or in terms what you call blockchain. Now here, because it's open for everyone, who is taking care of this privacy and authenticity. Now the data transaction belong to various clients. Privacy and authenticity needs to be ensured. Okay, because it is an open network, distributed network, everybody can see what is happening in the network. Okay, so the users must be an authenticated one. Okay, let us come to the formal definition. So far I've explained what we have done, what we people have been done during this, so many years before blockchain. Now how the blockchain came into existence. Now, as I mentioned in the previous definition, that it's an open, anybody can be a part of that network. It is a distributed ledger, everybody has got the same copy in the account or on the node, that can record transaction between two parties efficiently and in a verifiable and a permanent way. Verifiable, why verifiable? In the sense that whatever the transaction that you are making, it is verified by the other persons in the network, whether the transaction is valid or invalid. Okay, and once you make a transaction, it is nothing but it is immutable, you can't change that. Once the transaction is committed, you can't edit and you can't change it. Okay, so that is a permanent. So there's a first verifiable and permanent way is given by Lancity and Lakhani in 2017 in a business Harvard Business Review, what you call the truth about blockchain. So he has categorically mentioned these terms specifically for blockchain. It is accessible to all. It is a decentralized environment. There is no central server or a central party. It is very efficient, fast, and scalable. Whatever the transaction due, that should be a valid one. It is verified by each and every individual in the network to make the validity, and it is permanent. Once you make a transaction, you can't edit or you can't delete it. If you want to make a new transaction, it should be a fresh one. So the information is here is persistent and it is tamper proof. Nobody can change whatever the once the transaction is committed, okay, and validated. So that's why it is called tamper proof. Okay, so all these terms plays an important role as far as understanding the basic mechanisms of blockchain is concerned. Now, coming to the basics or the historical perspective, because blockchain, the mathematical background behind blockchain is nothing but what you call cryptography. Okay, so cryptography provides the security to the entire blockchain. Okay, because it provides the concept of what you call hashing. Okay, in mathematics we call it as hash functions. So what this hash function does, it map any size data to a fixed size. Okay, whatever may be the data, image, video, anything that you pass to the function, the result should be a fixed size. Okay, maybe a 64 characters. Okay, for instance, I have a function, okay, h of x, where x percentage of n, x is nothing but the value that you have given, the variable, and n are nothing but integers. Okay, so there is nothing but a modulo. In computer science, you take the remainder of this. So this percentage is nothing but a modular operation. Okay, so once you divide x by n, whatever the remainder, that is your answer. Okay, we call it as percentage is a modular operation. Okay, there is nothing but remainder. Now x can be of any arbitrary length. Your input may be of any size. It may be any video, any image, whatever it is. Okay, but the output is only of fixed size. Okay, so x can be of any arbitrary length, but hx is within the range. What is that range? 0 to n minus 1. Okay, so there is a range as far as your output is concerned. So when I say cryptographically secured, in the sense that given x, we can compute the hash of that, but the reverse is not true. But given x, h of x, no deterministic algorithm can compute x. Okay, so it means what? It is only one way. You have got an x, you find hx, but the reverse is not feasible. Okay, so for different values of the variables like x1 and x2, you can have different hash values, and they should be different. Okay, there are various mechanisms as far as the hashing is concerned. We have um, message digest 5 or secure hash algorithm 256, we call SHA 256, and there's a hashing mechanism that is generally used in blockchain. Okay, so whatever the message you give, you just do the hashing of that for security purpose only. Okay, we call it as message digest. Okay, your input is nothing but a message, you pass it to an activation hash function so that you'll get message digest. Okay, now you see here I've given a simple example what is hash function here. Okay, so for instance I have given an input mouse. Okay, pass it to an activation function h of x, then you'll get this 64 characters. Every character is of hexadecimal, there is nothing but 16 bits. Okay, now the blue mouse jumps over the green cat. Okay, so there is a statement that you have inputted, pass it to the activation yeah, hash function, you'll get this. Now you see small change I have made here. This overspelling is over, just make a small change here. Instead of v you can write u, the entire hash value has changed. Okay, similarly I have shown for other small changes, even a small dot you put, the entire output changes. Okay, so this plays an important role as far as providing security to the information in a blockchain environment is concerned. Okay, so the avalanche effect, it says that a small change in the data results in a significant change in the output. Okay, even if I put a dot here, the entire hash value changes. Okay, so this is what it says, whatever the length, input length you give, the output is always fixed of 64 characters or 256 bits. Now, how this plays an important role as far as providing security in the blockchain is concerned. Okay, we call it a secure chain of blocks. Okay, now there are researchers called Haber and Storinita in 1991. So they have done a time stamping of a digital document. How they did it? There is a sequence of timestamps. Okay, for instance, so here a timestamp. Timestamp is nothing but time that at what time this particular transaction has been generated. Okay, so I have got some parameters here, and there's some parameters I have sent, and there's nothing but the initial hash h0. Now the entire terms are now hashed h1. Okay, now in h2 I have got the previous hash and with new information along with the timestamp. Okay, for instance there's some information is there, there's another information, some information I have added along with this hash value. The initial hash value is h0 for instance. Now the complete information is now hash, I'll got a new hash h1. Now this h1 acts as one of the important part, what you call previous hash, for the next block consisting of some additional information. You see new timestamp, new values are there. Okay, similarly for h3, h2 acts as a previous hash. Similarly for h4, h3 acts as a previous hash. Okay, so this is what you call timestamp a digital document, so that any change you make anywhere in this document, okay, the other hash values also changes. Okay, so the sequence of timestamps that I mentioned denoting when the document is created or updated, at what time this particular document is updated. The document may be C1, C2 with some other transaction. Okay, so whenever a client accesses a document, construct a block consisting of sequence numbers of accesses like 0, 1, 2, 3. They are sequence numbers. Then there is a client ID C1, C2, C4. There is a timestamp when it is created, when it is updated, and the hash resultant hash value from the previous request. And the entire thing is hashed to connect it to the previous block. Now this entire thing forms a chain. Okay, so whatever the change you make inside this, the entire hash changes. If this hash changes, this also changes. Okay, so whatever the changes you make, this entire changes will be reflected in the corresponding subsequent blocks as well. Okay, so that's why it is called a tamper proof. Once you committed some transaction, you can't change or edit it. Or if any malicious uh, intruder comes and tries to change or hack your network, it will be easily caught. Okay, and it is not feasible easily to change such type of to update such type of blocks in the network, because it is cryptographically secured chain of blocks. Okay, so this was the first concept as far as providing security to the documents are concerned, especially what we call digital documents, and it was introduced by Haber and Storinita in 1991, and the same concept was adopted in blockchain as well. Okay. Now there is another important fact called Merkle tree. Okay, Merkle tree also uses the concept of hashing. Okay, so also known as hash tree. Now you'll find a lot of leaf nodes here. Okay, now I've got several documents D1, D2, D4, D3, and D4. So every leaf node is labeled with the hash of a data block. For instance, I have a some information of some data is there. You do a hashing of this, you'll get the resultant hash here. Similarly, here also you do the hashing, get the resultant one. Okay, so every non-leaf node is labeled with the cryptographic hash function of the labels of its child nodes. Okay, so these are my childs, these are my parents. Okay, what the parent is doing, a parent is adding all the hashes. So one hash you are coming here, another hash is coming, again you get addition of this, then again you take a hash of this, you'll get a new hash here. Okay, so we are securing 4 documents here, D1, D2, D3, D4, together with a root hash value. That value will be propagated, and any change in the document effectively reflect the change in the root hash value. So this is my root hash value. Okay, it contains what? It contains the information about all these 4 documents in a secured manner. Okay, so this document is hashed, this document is hashed, both hashes you add, again you get a new hash. Okay, and you pass it here, this also you pass it here, now you'll get the root hash here. So what the root hash says, root hash is nothing but the information about all these 4 blocks are there in this root hash. Okay, so any intruder or any changes you make anywhere in this particular tree, it is going to change the root value. Okay, so this is how the security is achieved as far as this particular network is concerned. So this way we can collectively secure the number of documents together by using a concept of Merkle tree. Okay, so Merkle tree is one of the important mechanism as far as providing security to the information is concerned. So we use this Merkle trees. Okay, Bayer, Harber, and Stornita used Merkle tree in 1992 for time stamping and verifying a digital document. So there's nothing but improved the efficiency by combining the time stamping of several documents into one block. Okay, so a block may have several such transactions. Okay, so other uses of Merkle trees, a peer-to-peer network, the data blocks received in undamaged and unaltered. Other pairs do not lie about a block. Okay, so because it's a tamper-proof, once nobody can change whatever the information that is there. If any intruder wants to change anything, it will be caught. Okay, because a slight change in anywhere, it will change the root value itself. Okay, now coming to this implementation of Bitcoin, a shared information is unaltered and no one can lie about a transaction. Why no one can lie? Because everything is visible in the network. Whatever the transaction you do, it will be visible in the network. Okay, and the shared information is unaltered because it is committed in the network. So this is what Bitcoin implementation is. Okay, now because we are all aware of Bitcoin. Okay, so it came into existence in 2008, introduced by Satoshi Nakamoto, and he released his first Bitcoin white paper. And in 2009, the entire implementation taken its actual shape. Okay, where he has written a paper called Peer-to-Peer Electronic Cash Digital Asset Transfer System. So there is a first paper that is published by Satoshi, and what you call a Bitcoin white paper. Okay, so Bitcoin is a completely decentralized peer-to-peer means every node is connected to every other node. Okay, permissionless. You are not anybody can be a part of this network, and Bitcoin is nothing but a cryptocurrency. Okay, in short form we call it as BTC is a cryptocurrency. Okay, so what is the definition here as far as a Bitcoin? So Bitcoin is based on blockchain technology. Okay, so it's a completely decentralized. There is no central authority like in banks we have a central authority there. Peer-to-peer, a software that runs on machines of all stakeholders to form the system, and it is permissionless. No identity, no need to sign up anywhere to use, no access control. Anyone can participate in the network. So there is nothing but permissionless. But all this raises some issues here. Okay, because if you are not an authenticated person, you may hack the network. Okay, there are some issues are that we'll discuss that. But meanwhile, as far as uh, Bitcoin is concerned, so Bitcoin is nothing but a cryptocurrency, and it is working based on the blockchain technology. And the blockchain technology provides this important mechanism, like it is a decentralized peer-to-peer and a permissionless network. If you take a look on the current scenario of the Bitcoins or a cryptocurrency, as on 24th March at this particular time, I have noted this information that one Bitcoin is around this many rupees. Okay. Similarly, we have Ethereum. Ethereum, one Ethereum is nothing but one Ether is nothing but this many rupees. Like this, there are several cryptocurrencies are there. At the top, we have Bitcoin. Okay, one Bitcoin is around this much on this particular date. It may be changed frequently. It is changing. Okay. Now, Bitcoin block size as on 24th March that I have recorded is around 4 gigabytes. Okay, because it's a chain of blocks. The entire blockchain size is around 400 gigabyte. And you see here on 2009 it has started slowly. On 2012 people have started taking interest in cryptocurrency. Now you see the scenario. Okay, around the blockchain size is around 400 gigabytes. Okay. So it is still growing. So Bitcoin price as on 24th March that I have already shown. Coming to the previous example that I have given, as far as the banking sector is concerned, what is the technology behind this Bitcoin? There is nothing but a decentralized ecosystem provided by the blockchain. Okay. Now the same example I'll take. Okay. Everybody has got whatever the transaction that make, everybody has got the same copy here. Okay. Now, a block may contain multiple transactions and every individual has the copy of the blockchain. So this is what we infer from here. So a block is nothing but several transactions. Okay, so the entire block, once it is valid, it may be a part of the blockchain network. Okay, so that's why a block may contain several multiple transactions. Several transactions I have shown here. Whatever the transaction you do, it will be added in the block. Okay, so there may be multiple transactions in a block and every individual has got this copy. Okay, so that's what Bitcoin also, because it is also implementing blockchain technology of a distributed environment. So the life cycle of a Bitcoin transaction, for instance, there is a person called Jay. I'm taking the same example. Now, how he is doing a transaction with Bitcoin? He just open a Bitcoin wallet. Okay. So when Madhusa takes a lab on Ethereum and all, he'll tell about one of the important wallet called MetaMask. This acts as a plugin to Chrome and Firefox. So if you want to do some transaction, you have to create a wallet. Okay. For instance, Jay opens his Bitcoin wallet and it seems like this. Okay. So this is a Bitcoin wallet. Now he wants to send some Bitcoins to person called Viru. So if you want to send some Bitcoins, you must know the account number. Okay. So provides the address of Viru and the amount to transfer and sends. Okay. Now whatever the Bitcoin foreign, he will send to Viru, and Viru has got his own wallet. Okay. Okay. I'll show in the next slide. So meanwhile, whatever the transaction that the J wants to commit, he want to send some Bitcoins to Viru. He will put the address of Viru. Okay. And whatever the amount of transaction that you want, it will come and you'll press the send button and the amount will be credited into Viru's account. Okay. Now what happens in the Bitcoin life cycle? The first one is the network. Okay, because you have to establish a connection, then only you can send the Bitcoins. Okay. So the wallet constructs the transactions, sign using J's private key, and broadcast is to the network. Okay, because whatever the information that you are sending, you will be sending it through some digital signatures. Okay, so we use some concept like public key cryptography. Okay, so every private key has got his own public key also. So one private key, one public key, they forms a pair. Okay, so before initiating the transaction, the wallet takes the responsibility of that. Okay, is generate a private and public key. So the how will this private and public key works? When I say publicly, is nothing but your account number or your email ID. So if I know my email ID, then only I can send the email to you. If I know your account number, then only I can send money to you. So your public key is nothing but your account number. Then what is a private key here? Private key is nothing but your pin number or a password. Okay, that you are not revealing with anyone. Okay, that is secure. Okay, the same thing here also. When you're sending a when you want to do some transaction, you must know the account number to where you want to send the amount. Okay, then you broadcast into the network. So the network node validate the transaction, because whatever the transaction that you are sending in a network, it has to be validated by each and every individual in the network, because it's a distributed one. Okay, so validate the transaction based on existing blockchain and propagate the transaction to the miners. There is another concept called miners that I'll tell, because in blockchain, who is going to validate the transaction? So there are persons in the network, or the clients can also be miners. They are going to validate your transaction. Okay, I'll tell how this miners do their job. But meanwhile, just remember that miners are the persons who are going to validate your transaction. And then once the transaction is valid, then they put that particular transaction inside the block in the blockchain. Okay, so the miners include the transaction to the next block to be mined. Okay, so there's a scenario that goes on as far as creation of the network is concerned in order to do some transaction. Next, as far as the life cycle of the Bitcoin transaction is concerned, the miners, as I mentioned, that miners are the persons who are going to validate your transaction. Once it is valid, they put into the blockchain. Okay, so the miner collects all the transaction, because a block may have several transactions. The miner's job is to collect all the transaction for some in Bitcoin. It takes 10 minutes to validate one particular block. Okay, so the miners collect all the transaction for the time duration, for instance, 10 minutes with reference to the Bitcoin. Okay, it takes 10 minutes to validate a block. And what they do, the miners construct a new block and put all those transactions and tries to connect it with the existing blockchain. So cryptographic has computations. Okay, I'll explain what this computation is all about. Okay, but for the timing, just remember that miners are the persons who are going to validate your transaction. Okay, and or whatever the transactions are there, all those transactions they will put in a block, and they add that particular block in the blockchain network. Okay, so once the mining is over and the hash is obtained, hash is nothing but they have to, each and every miner has to solve some computational puzzle. They have to find this hash value. Okay, so a lot of computation power is required for that. Okay, once they get the hash value, then those miners can validate the block, and for that they'll get a reward also. Okay, but for the time being, just remember that once the mining is over and the hash is obtained, how this hash is obtained I'll discuss. So the block is included in the existing blockchain. Okay, so the updated blockchain is propagated in the network. Okay, so this is what the miners does. The main job is, whoever do the transaction, you validate the transaction, you put in a block. Okay, the entire block you add in a blockchain. And a block can have several such transactions, because if I am sending some Bitcoins to you, there are other persons in the network, they may send to their respective friends to some Bitcoins. So there will be several transactions. Okay, so the miner will validate the entire block within 10 minutes with reference to the Bitcoin. Okay, now in the receiving end, as I've because the sender has created a wallet, and using that wallet he is sending the Bitcoins to the receiver. So what the receiver does, receiver opens his Bitcoin wallet. Okay, and he refreshes his, the blockchain gets updated and get the desired amount of this much. Okay, so I've started with a wallet of the sender. Okay, he has got a wallet with desired Bitcoins. Similarly, I've got a wallet for Viru. Okay, like in Phone Pay, Google Pay, we use our own wallets. Okay, so the transaction reflects at Viru's wallet once it is refreshed by the corresponding receiver. Okay, now this is nothing but what Viru receives. He has received the Bitcoin sent by the Jay. Okay, is the sender. Okay, He'll get all the information from where he is getting. Okay, so everything is hashed here. Okay, now Bitcoin is actually nothing but there are various versions of the blockchain, and Bitcoin comes uh, in blockchain 1.0. Similarly, we have blockchain 2.0, where we have Ethereum and smart contracts. So Ethereum is also one of the important blockchain. Okay, it's a like Bitcoin, but Bitcoin totally works on cryptocurrency. Ethereum also works in cryptocurrency called Ethers. Okay, but you can use for non-financial transaction also, because we academician, we are not going to invest such money in cryptocurrency, so we use for non-financial transaction. Okay, for securing medical records. Okay, or supply chain management. So we have wide variety of application nowadays. So in blockchain 2 we have got Ethereum and one more term called smart contracts, so that will be discussed by uh, another expert maybe probably tomorrow. But meanwhile, I'll give a general idea. A smart contracts is nothing but what? It's a simple program, okay, or what you call automated computerized protocol on a blockchain that runs when a predetermined conditions are met. Okay, so there is two persons are there, similar to what an agreement. Okay, that agreement is nothing but a software or a program where some if then else conditions are mentioned. Okay, so they typically are used to automate the execution of an agreement so that all the participants can be immediately uncertain of the outcome without any intermediary involvement or time loss. Okay, so each and every individual is certain that they are going to execute this particular smart contract so that the transaction is complete. Okay, so that's why they say that used for digitally facilitating, verifying, or enforcing the negotiation or performance of legal contract by avoiding intermediates. I don't want any intermediate in between. Okay, and directly validating the contract over a decentralized platform. Okay, and it is very fast, cheaper, and more secure. Okay, security is coming because of the cryptography. Okay, so for the timing, just remember that smart contract is nothing but a program where some agreement is written and the two parties will agree with this particular agreement. Then only the contract will execute based on some conditions. For instance, some I want to send my home, sell my home, house. Okay, and he is my sender and he is my receiver. Okay, they'll sign a contract. Okay, I you first send rupees 5 lakhs, then only I'll sell my house. Okay, this is an agreement. So once the agreement is appreciated by both the parties, then only this program will execute and validated in their respective nodes. Okay, so the smart contract was coined by Nick Szabo, a computer scientist and a cryptographer in 1996. So what he claimed that smart contracts can be realized with the help of public ledger. Public ledger is nothing but blockchain. Okay, so blockchain can be a pioneer technology to realize smart contract. Okay, so as I mentioned that the blockchain at the beginning, the first version we have got the Bitcoin. The next version we have got smart contracts with Ethereum, Hyperledger, and other smart contracts. In three, we have decentralized applications. Okay, like electronic voting, healthcare, security, providing security to health records. Okay, supply chain management. Okay, notary systems. So they all works on decentralized application. Okay. The next in blockchain 4, we have all industrial applications. Okay, use of IoT, use of machine learning, AI. Okay, now AI is also coming into picture. They are clubbing IoT, AI, ML, and all with the blockchain. So that is taking the shape of version 4.0. Okay, so here I have mentioned the chronological order, the origin of Bitcoin, then blockchain 2, 3, then currently we are in blockchain 4 because we are integrating with IoT, AI, and big data also. That is from 2018 and till date. Okay. So when I say that smart contract, now before understanding the smart contract, let me explain what this crowdfunding is. Okay. So crowdfunding actually that is also a contract, but in a centralized platform. Okay, so there are several crowdfunding companies or startups are there. For instance, Kickstarter, peer backers. If you talk about an example of a Kickstarter, okay, for instance, Kickstarter is a startup that does crowdfunding. Okay, so what crowdfunding is actually all about? It is a centralized platform. For instance, you have an interested project, but you do not have sufficient money to execute the project. Okay, so you have a project, but you don't have money for that particular project to execute that particular project. Now, what crowdfunding platform does? You submit the project in a crowdfunding platform. There are so many crowdfundings are there, like startups, like Kickstarter and all. You submit your project to them. Okay, and there are multiple supporters who commit to support the project with small funds. Okay, there are several parties are there. They want to support your project. Okay, and they directly contact with this company to whom you have registered your project. Okay, now the platform ensure that you get the complete money if the project is successful. So I'm talking about Kickstart. There are several companies are there. Okay, so these platform ensure that you get the complete money if the project is successful. Now here the Kickstart is nothing but a central authority here. Okay, and there are several multiple supporters who are investing some small funds to make your project success. Okay. Now, both the project and the product team and supporters need to trust crowdfunding platform, because you have submitted your project, somebody is putting in that, both are connected with the central authority, is nothing but crowdfunding platform. For instance, Kickstarter. Then you must have a trust. Okay. The product team expects the money to be get paid based on the project progress, because this is your project. Once you have, because you have signed an agreement with this platform, so once you do the project, you must get the money from the this particular startup. Okay, so the supporters expect the money to go to the project. Okay, so there is a project team, there is supporters, they are sending money to here. Okay, and they also want that whatever the money they are sending, it should reach to you. Okay, so however, the crowdfunding platform, the mediator, the middleman, or this particular person, the mediator takes sufficient charge to manage the entire process. The Kickstarter, you take sufficient money in order to execute that particular project. So that's why I mentioned the crowdfunding platform, the mediator or the middleman takes sufficient charge to manage the entire process. Okay, so this is what I have mentioned. Now just replace that, the central authority, with smart contract. Okay, now I have removed this particular person. There is nothing but Kickstarter. Okay, the crowdfunding platform I have replaced with smart contract. Okay, now I've got the supporters, I have got the product team who want to execute their project. Okay, now you sign a contract. Now a copy of the contract you will find with every supporter as well as the product team. Now the contract is written in a code, because it's a software or a program which is available to all the stakeholders. So what are the stakeholders I have? I've got supporters, I've got product team. Everybody must have this copy, as I've shown in the blockchain also. Everybody must have their one copy of the blockchain or the distributed ledger. Everybody must know what type of transaction is taking place in the network. Same thing here also. So you write a code or a contract which is available to all these stakeholders about that particular contract. So obviously you see here the application of blockchain. Okay, everybody has got the copy of that ledger. Whatever the transaction that takes place, it is visible to everyone. Okay, so that's why crowdfunding using smart contract. So if if certain goals of the project are reached, the code automatically transfer the money from supporters to the product team, because you have signed an agreement. Everybody has got the copy of that contract. There are some goals are mentioned. If some portion of the project is completed, then you send this much amount of money to the product team. Okay, so that's why if certain goals of the project are reached, if the project started and got completed to some phase, then they must receive the amount. Okay, so the code automatically transfer the money from supporters to the product team. Why? Because they have written a code or a contract in such a manner that if this much percentage of the project is completed, then they'll transfer this much amount of money. Okay, so that is signed and agreed by each and every party that is involved in the network. Okay, the supporters and the product team. Okay, so this is how now crowdfunding is replaced by the central authority. The crowdfunding platform is now replaced by smart contract, using smart contracts. Okay, for instance, if the project fails, or the contract fails, if the goals are not met, then the code automatically transfer the money back to the supporters. Okay, if the people, they have submitted the project but the project is not successful or it is failed, you then the product team has to return the money to the supporters, and that is taken care by this particular smart contracts program. Okay, so the code automatically transfer the money back to the supporters. So this is how smart contract works. So what are the positives here? It is immutable. Okay, in the previous in the earlier also I mentioned that whatever the transaction that you make, it can't be changed or modified. It is immutable. No party can change the contracts once it is fixed and written to the blockchain. So once the program or a contract that is written, that is a copy with everyone. Okay, so nobody can tamper with it. It is immutable. So once it is fixed, so it is distributed because it's a distributed ecosystem. Okay, so all the steps in the contracts are validated by the participating parties. So whatever the parties have shown in a crowdfunding, the supporters, the project team, everybody must agree with that contract. Okay, so all the steps in the contract are validated by those involving parties itself. Okay, so why blockchain? Because the blocks are immutable and the information is open to everyone. Okay, so it's a tamper proof. The tamper proof security is coming because of the cryptography. So there are several such smart contract platforms are there. Okay, so you will do lab sessions. How the smart contracts is written is Solidity. Proposed by Satoshi in 2010, but nowadays the block size has gone to around 400 MB as I've shown. Okay, 400 MB of around 400 gigabyte. Okay, so earlier the block, according to the Bitcoin block or the Bitcoin that has network created by Satoshi, so a Bitcoin block may contain more than 500 transactions, and the average size at that time was 1 MB. Now it has grown to 8 MB or more. Okay, because if you Google it, you'll find more than this. Okay, so the larger blocks can help in processing of larger number of transactions. So more number of transaction in a block, then more amount of information can be processed in a shorter span of time. Okay, you see a Bitcoin block is there. Okay, so there are so many transactions. There is a previous block, hash of previous block. Okay, so block number, block size, and there is a block header. I'll explain what this block header, what transaction size, and all those transactions. So there are two things as far as the block structure of the block is concerned. One is block header and other is the transaction. So in the block header, you find all those information, the version, previous hash, the Merkle root, the timestamp when it is created, difficulty level. I'll tell what this difficulty level is. Then the nonce. These terms I'll just give a general idea so that you can remember. Okay, and there's a commonly used secure hash algorithm, what you call SHA-256 in blockchain technology. So what is important here? The block header and the list of transactions. Okay, so you see here, there's an example that I've already discussed, that whatever the information that you have, it has to H1. The H1 acts for next block hashing. So next block has got this many information, timestamp, client ID, the other information along with the previous hash. So now this create a chain. It's because every block has got the previous hash number. Okay, see, every block has got the previous hash. So this block has got previous hash, this block has got previous hash. So this creates the chain of the blocks which are secured. So any changes you make anywhere, it will be reflected in the corresponding hash. So that's a tamper proof. Okay, so this is how a simplified blockchain looks like. That every block has got a previous hash, timestamp, nonce, Merkle root. Merkle rule I have discussed. Timestamp, nothing but the time creation of the blocks, the previous hash, and the nonce. Nonce I'll just tell with an example. Okay. So the beginning block is nothing but Genesis block. That is nothing but h of 0. Okay. So that acts as a previous hash for the next block. Okay. So the block is record that contains the data and details of the transaction. It comprises all these elements. Okay, hash of the previous block, nonce. Nonce is nothing but number generated once. There's a random number used to vary the value of hash. Okay, so I'll explain the importance. So Merkle root, okay, there are all those transactions. They'll will be represented with one particular hash value. Okay, so a hash of all hashes created from all the transaction in the block. So whatever the transaction you have, all the transaction have their corresponding hash, and they got one Merkle root. Okay, so every block can have several such transactions. So this is how the blocks are connected. Now coming to the mining, because somewhere I mentioned the term nonce. Okay. Now the miners plays an important role as far as validating the transaction in the network is concerned. Okay, because it's a distributed environment, every node or a person has got the copy of the distributed ledger or a blockchain. Who is going to validate the transaction that are made? The miners plays an important role here. So let's see what mining actually means with reference to the Bitcoin. Okay. So the mechanism to generate hash, okay, makes the blockchain tamper proof. Okay. We know what the hash values are. We have already discussed. Now Bitcoin mining is nothing but hash, is nothing but previous hash plus this is nothing but OR sign. The transaction plus the nonce. There are three parameters are there. The nonce, whatever the transaction, and the previous hash. Okay. All this hash together, you'll get this h of k. Now find the nonce such that hk has certain predefined complexity. There is nothing but number of zeros at the prefix. The miners that I mentioned, the main job of the miners is to find the value of nonce. Okay. So the nonce is nothing but it is a 32-bit number. Okay, so 32-bit number, and the entire hash is of 64 characters. 64 characters, and every character is of 16 bits. Okay, so total size of this is nothing but 16 to the power 64 hash values can be generated. Okay, so this is around 10 to the power 77. Just imagine the number, how many hashes can be generated. Okay, so hope you remember that in a when you're using star 256, whatever the input you give x of any length, the output is of fixed length. Okay, fixed length of 64 characters, and every character, each character is of 16 bits. Okay, so total size it becomes 16 to the power 64. Okay, so this many hash values can be created. Okay, now this nonce is nothing but it is of 32-bit. Okay, so in order to find, because as I mentioned that the miner has to find the value of this hash values. Okay, and it requires huge computation power in order to find these values. Okay, because I know that I can, whatever the inputs I am giving and I can get the output, but the reverse is not true. Okay, so that's why the miners has to find this nonce so that it will match with the corresponding hash value. Okay, how it is done you see here. Now since there are 16 to the power 64 hash values are generates a huge number, but the miners has to generate how many nonce? 32. 32 bit is nothing but 2 to the power 32. So it comes around 4 billion, or around 4 to the power 10 to the power 9. 4 into 10 to the power 9, around comes 4 billions. 4 billion nonce can be generated by a miner. Okay. Now for instance, assuming that one nonce generated per second is for instance 10 to the power 8. nonce per second. Okay. Now a miner can generate this 44 to the power 10 to the power 9 or 4 billion nonce in how many seconds? This 4 into 10 to the power 9 total nonce. Okay, for one nonce he generates, it take 10 to the power 8 um, nonce per second. So you divide it by 10 to the power 8, it takes around 40 seconds. Okay, so the miners are available with 4 billion nonce. Okay, and they are going to consume within 40 seconds. What about the remaining hash values? Okay, for instance, I have got the nonce here, they are around 4 billion, and I have got total hash values is nothing but 16 to the power 64. It's a huge number. Okay, 16 to the power 64. But if the miner generates this many nouns, nonce or 4 billion nonce, and he can generate within 40 seconds, and every nonce value is tried to map with the corresponding hash value. If it matches, then the transaction is valid and the block is added to the blockchain. If that nonce value and the hash value is not matching, then the block is not validated to the blockchain. Okay. Is that okay? Now the question arises, if there are 4 billion nonce are there and 16 to the power 64, hope my screen is visible, this many hash values are there. Now, if 4 billion nonce are generated by the miner and it is not matching with that 4 billion hash values, then what happens? What happens with the remaining hash values that are left? So for that, we have a concept called timestamp. So every block has got a concept called timestamp. As I've shown here, you see some timestamping. Now, as soon as a particular block is added, a transaction is made, this particular time increases. So as soon as this increases, because a block contains so many parameters, the nonce, timestamp, your transaction, okay, and then finally the hash value. So whatever the change you make, it results in the change in the hash value. Okay, so as soon as a timestamp changes, the hash value changes. So as soon as the hash value changes, again you are going back to the previous nonce value. Okay, so that's why this nonce of 4 billions is never consumed. Okay, because every timestamp again it reaches to the 0 point. Okay, if you have a scale of 0 to 400 billion nonce, if you have consumed this much, okay, and you have left with this much, because at every timestamp this again reaches to the 0 point itself, because whatever the small change you make here, if the timestamp changes, this hash value changes. So hash value changes means the nonce again comes to the 0 point. Okay, so that's why this is never consumed. Okay, so only thing that you remember, that the miners has to find this values of nonce, and they'll give a predefined target if they're nonce, for because they have to solve this puzzle so that they'll get this hash value. Okay, and generally there are around few number of zeros, maybe 25 zeros at a prefix. Okay, so depending on the algorithm, it will be set. If the miner solves that puzzle and this nonce it keeps on changing, if it is matches with the hash, then the block will be validated into the blockchain and you will get some rewards. So in case of Bitcoin, the miner will get some Bitcoins as a reward. Okay, so that is why it is a lot of complexity is involved in order to solve this particular hash puzzle. So so these are the details of the block. Okay, so in Ethereum we have an etherscan.io. You'll find this information when you learn Ethereum. Okay, so this is with reference to the Bitcoin. You'll find the difficulty level, the nonce, the bits, size of the block, the weightage, the version, the nonce. Okay, and because he is a miner, he's mined that particular block and he'll get some reward. Okay, so timestamp is given, receiving time, transaction fees, because some transaction will be once you make a transaction, the fees will be there, transaction fees. So we call it as a gas in Ethereum. So transaction volume, okay, number of transaction, every information you'll get. Okay, in bitcoin.com you'll get, or in etherscan.io you'll get all the information in the current scenario, what is happening with these blockchains. Okay, so in the blockchain we have a concept called block header. So where you will get hash value, the previous hash, the next block hash it is connected, and the Merkle root. Okay, so the etherscan that I mentioned, okay, you can refer to this site. Okay, so there you see the transaction has the status, whether the block is validated or not. Okay, so you click on the block, you'll get the entire information. Okay, from where and to whom you are sending. Now everything is encrypted, you see. So everything is encrypted using that hash function SHA-256. Okay, so the identity is never revealed. Okay, so the value, the transaction fees, the gas price with reference to Ethereum. So there is with reference to the Ethereum blockchain. Okay, if you want to see what is there inside the block, what is a from where, who is a miner, at what time these blocks are getting validated in the blockchain, every information you'll get from this site, or blockchain.com also you can see. So let us summarize what we have discussed. As far as the block is concerned, a block contains a block header consisting of all information about the block and all the transaction. So the header of the block contains the transaction. Any change in the transaction will result in the change of the header itself. Okay, and the header of the subsequent blocks are connected in a chain, as I've shown in the example, and the entire blockchain needs to be updated if you want to make any change anywhere. Okay, so any change you make anywhere, the entire blockchain has to be updated, because each and every node has got the copy of the blockchain. Okay, so that's what we call replicas in blockchain. So every peer maintains a local copy of the blockchain. So what is the requirement? All the replicas need to be updated with the last mined block. Okay, and all replicas need to be consistent. Consistent in the sense every node in the network must have the same copy of the blockchain at a particular time. Okay, so this hashing algorithm that I've already discussed. Okay, so the same thing here also. So what SHA-256 is doing is taking all the parameters, block of transaction, nonce, and previous blocks, then is giving the entire hash, and this has to be find out compared with the corresponding nonce value. Okay, with the miner. Okay, so miner has to change every time the nonce value. There are 4 billion nonce can be created, and every nonce he'll compare a slight change, then he'll check with the hash value. If it is matching, then only he will win. Otherwise he has to keep on trying and solve that particular hash puzzle. Now there is one more term called distributed consensus, because it's a peer-to-peer network. There is no central authority here. Everybody has got a complete authorization of making transaction. Okay, but whatever the transaction they make, the transaction is validated based on consensus. Okay, so this consensus algorithm plays an important role in a blockchain ecosystem. Okay, so ensure that different nodes in the network see the same data at nearly the same point of time. Okay, and all nodes in the network need to agree or consent on regular basis. Okay. Am I audible?
Yes, sir.
Yeah.
Audible.
I'll just take 5 minutes. Okay, I'll just explain what this consensus is, because as I mentioned that different nodes in the network see the same data. Everybody has got the same copy of the document or a public ledger, same data at nearly the same point of time. That is what consistency is. All nodes in the network need to agree or consent on a regular basis that the data stored by them is the same. Okay, same copy of the blockchain should be available at a particular time on every node. No single point of failure. So that's why the data is centralized, because we don't have a central authority. We don't like bank. Bank is a central authority where all the transactions are maintained. Okay. So here in a distributed environment, there is no single point of failure. Okay. So the system can provide service even in the presence of failures. If one node fails, you can work with another node. Okay. So that's what the concept behind decentralized network. So in distributed consensus, starting from early 90s when blockchain came into concept started evolving, a large number of works have been devoted on the development of this consensus algorithm. Most of the distributed networks, they use this consensus algorithm. So the basic philosophy is inform your current state to others so that everyone can match their current state with others in the network. So this is a basic idea in a distributed consensus. Okay, whatever the changes you make, you inform everyone. Okay, take their consent. Okay. So, however, this philosophy requires that the participants in the consensus algorithm knows each other. So, this is very important. Okay, but in Bitcoin, it is open to everyone. Everybody can be a part of that Bitcoin blockchain network. Okay, but there are some issues as far as malicious attackers can hack your network. Okay, so there is a concept called 51 attack or 51% attack. So more than 51%, if they agree, then for instance, I have 51% persons who want to hack that particular network. So 51% have got the consensus that they are correct and they may hack that particular network. Okay, so this possibility is there. Okay, but we have different algorithms in order to tackle this. Okay. So can we achieve consensus even when the network is arbitrarily large and no participant in the network really knew all other parts? Is it feasible that in a network when you want to do some transaction where the other party who is involved in the network, how to know their identity, because everything is hashed here. Okay, so can we achieve consensus even when the network is large and no participant in the network really knew all other participants? So an open network scenario, the permissionless protocol, you do not record your identity while participating in the consensus system. Okay, so there's a key here. So we are not revealing our identity, even our account number is hashed. Okay, so a challenge response based system, there is nothing but network would pose a challenge and each node in the network would attempt to solve a challenge. What is a challenge? That it's a open network scenario. Okay, so whoever involved in the network, they should must agree with their respective activities. Okay, so that's why you do not record your identity while participating in the consensus system. Okay, if they reveal the identities, then there may be a possibility of hacking the system. Okay, I think I'll stop here because it's already 8:10. Okay, because these portions will be covered by the next expert, I think. Madhu sir, consensus algorithm will be covered by some other expert, right? Madam?
Yes, sir. Yes, consensus and other algorithms will be taken by other person. Sir, I have one doubt. When we are considering the smart contract, like as digital transaction, who validates the block data or transfer of data? Sridhar, sir, am I audible?
Hash puzzle has to be solved by that miners. So they are going to validate your transaction and they validate the entire block.
Okay.
So the miners are the people who are going to validate the block, and once they validate the block, they put it in the blockchain. So the algorithm take care of everything. So we are not going to do anything. So because in the lab session, the Madhu sir will explain you how the wallet is created. In Ethereum, we have various test network like Rockston and Ringb, and then the Ganache is a dummy blockchain network consisting of 10 accounts. He will help you in the lab session already how this blockchain actually works, how you can create because you can't create Bitcoin now, but you will create ethers. Okay, ethers is also a cryptocurrency, but a dummy ethers will be created by using a wallet called MetaMask. Okay, through wallet you can do transaction in Ethereum. So in the lab session, he will explain nicely whatever the theory concept that I given. The same thing he will implement in the lab session also.
Okay, okay, sir. Okay, sir.
Any queries from the participant side? How many attendees are there? How many participants are there?
Present now 45 are there.
45.
45.
Okay, so it's nice number. Madhu sir? So thank you so much, madam, for giving me this opportunity.
Hello.
Madhu sir.
Sir, am I audible, sir? My
Yeah.
internet is shaky. Am I audible, sir?
Yeah,
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 yeah.
sure. Go ahead, sir.
Hello.
Yes, sir. Go ahead.
Am I audible, sir? Hello.
Yeah, yeah.
Yes.
You're audible, sir. Go ahead. I think
Sir?
most, yeah, yeah. I think most of the participants are attending from the respective residences, right?
Yes, sir. Starting there 64, present there 45, they're still in line.
So if
Fine,
the participants have
sir.
anything, if they have any doubts, then they can mail me. Okay, they can get the mail ID from Madhu sir, so that I'll explain in detail, especially the nouns and finding the hash values. Okay. Yes, Madhu sir.
Sir, not audible. Madhu sir is not audible, sir.
There is some internet issue, I think.
Okay. Okay. Thank you, sir. Thank you so much for
Welcome.
giving an overall introduction of blockchain technology, the evaluation of Bitcoin, smart contracts, and Ethereum. And a special topic we observed as a crowdfunding.
Yeah, yeah.
Regarding of that, we have no idea about that.
But I have explained the basics. I have already mentioned there what crowdfunding, what people used to do.
Yeah.
Earlier it was central authority is there. Okay, they
Okay.
charge money for that, but
Mm.
nowadays they're using smart contract, so people are
Oh.
saving money in that.
Yes, sir. And evaluation of a black size and the
Yeah,
structure of blacks, Merkle tree, Merkle roots, and nonce, and everything. Have to got a good idea about all these things. And
okay.
thank you, sir. Thank you once again for giving
Thank
this opportunity to join with our Malineni.
Welcome, madam. So namaste, madam.
Thank you, sir. Madhu, sir, are you there? Ramesh?
Madam, I think there is some network issue at Madhu, sir.
Okay. You can conclude.
Thank you all the participants for your patient listening. Thanks to the speaker, Dr. K.
Thank
Sridhar Patnaiak, sir, for giving us a detailed overview about the blockchain technology. You have given a wonderful introduction, sir. It's a very pleasure for us to listen from you.
welcome, sir.
Thanks for all the participants. We will have tomorrow's session, that is continuation of SAR session. Dr. P. Radhakrishna Garu. He'll enlighten us with smart contracts. Thank you, one and all.
Okay, thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, one and all.